Hello everybody. In this video I'm going to take you through calorimetry. Calorimetry is a laboratory technique to figure out the change in enthalpy or the heat of reaction, okay? As opposed to the heat of formation data tables and formulas and stuff you'll learn a different way, all right? If you have a thermochemistry or a coffee cup calorimetry lab, this is the video you should be watching. Now we call this a coffee cup calorimeter because quite literally it's done in these really cheap styrofoam cups, all right? It utilizes the property of water, which has a specific heat capacity of 1. Please memorize that. A reaction can absorb or release heat. So for example, if a reaction releases heat, the water is going to warm up in temperature as this progresses because it's an insulated container, okay? And so we can measure that change in temperature with a thermometer. We can plug it into Q equals MC delta T to find out the heat flow. And then I'll explain these last two bullets later on in the talk. Delta H is equal to negative Q. And then we can calculate something called the delta H reaction. See how the RxN there is there? So there's a different formula for that, okay? I think it's best if I just show you a little demonstration of this. So what you'd want to do here is weigh out your chemical. And so here I'm weighing out 4.31 grams of ammonium nitrate. And this is going to react with just pure water. So the next thing I want to do is measure out a known certain quantity of water. Here I'm measuring out 50.0 milliliters of water. Pretend like I'm doing this on a table and I'm carefully reading the meniscus and all that. Good enough. All right. So 50.0 milliliters of water. And as I'm going through this, I'm going to put all of the data here on the left. Okay. The next thing you want to do is measure the initial temperature of the water. Remember, it's the change in temperature you're interested in, so you need 2 temperature readings. All right, you stick your thermometer into water, you wait for a couple minutes, and you just wait for it to reach thermal equilibrium. In this demo, I got 20.9 degrees Celsius for the initial temperature of the water. Now, what we're gonna do is mix these chemicals. When these two mix, ammonium nitrate is going to dissolve in water. When that happens, the crystalline lattice is broken apart. You form individual ions, right, that are surrounded by water molecules. And this is a dissolution reaction or a dissolving reaction, and there's generally heat associated with this change. So here I am, it's quick. You just mix the two chemicals together, and then it's convenient to use the thermometer to kind of just stir it, mix it up until it dissolves. And it takes a while for it to dissolve and also for the thermometer to reach thermal equilibrium and so on. And you read the final temperature, okay? I go ahead and write this down here and it's 15.3 degrees Celsius. So this reaction is kind of interesting. It's a cooling reaction. It starts out at 20.9 degrees Celsius and it actually gets colder and goes down to 15.3 degrees Celsius, all right? So let me take you through all of the necessary calculations to figure out the heat of reaction or the delta H reaction, all right? So first, always, you want to calculate the change in temperature. That's usually the easiest thing to do. Now, careful. Notice how in this example, delta T is going to be equal to a negative number. And you might be thinking, well, that's wrong. You know, it should just be 5 degrees or whatever that is on the screen. It's not. All right, because you want to take the final temperature and subtract the initial temperature. When you do that, 15.3 minus 20.9 gives you a value of negative 5.6 degrees Celsius. As I mentioned, the negative signs or the positive signs you get in thermochemistry are absolutely critical because they designate which direction the heat is flowing. All right. Next, we want to calculate Q. All right, and so what is the formula? Well, Q equals MC delta T, you're thinking. Well, what mass do you use? You might be thinking, well, the only mass on the screen here is ammonium nitrate, but that's not correct, okay? I always use these radiation symbols when there's a really cautionary thing to call out. Here, M refers to the mass of water because that's the substance that's warming up or cooling down in a chemical reaction. So don't forget the density of water is defined to be 1. So 50 milliliters, 50.0 milliliters is equal to 50.0 grams, okay? Now we plug it into Q equals MC delta T. It's the mass of water, the specific heat of water, and the change of temperature of water that gives you the heat of negative 280 calories. Notice how there's that negative sign there. Watch out for the signs always when you're going through things, all right? Now, normally we calculate this value in kilojoules, all right? That's the tradition. So you want to go from calories to joules and then divide by 1,000 to get your kilojoules. Now, the change in temperature is 2 significant figures, so we want to round this result to 2 significant figures, giving us negative 1.2 kilojoules. Now, here's where I want to pause, and I want to talk about a very important concept, okay? In calorimetry, the delta H is equal to negative Q, all right? And that's because I've bolded it here in orange. The water is going to release heat as the reaction absorbs it, right? So the reaction is absorbing heat, all right? The reaction is absorbing heat, and that's why the temperature drops, because heat is being sucked out of the water, okay, by the chemical reaction. And so the temperature goes down, all right? So the delta H is equal to opposite of negative Q. Now, you might be thinking, well, why is that? The heat has to go somewhere, okay? Heat is not being released by this chemical reaction. We're getting a negative value for Q, right? Q is negative 1.2. Let's go to that page. Q is negative 1.2. That suggests that heat's being released from a reaction and it's getting hotter, but it's not, okay? The heat is actually being absorbed. So we calculate delta H with this very simple thing. You just need to remember it. You change the sign. If it's plus, you go to negative. Here we have negative and we go to positive. So the delta H, or the change in heat or change in enthalpy, is plus 1.2 kilojoules. And that makes sense, right? Because this reaction is getting colder. It means it's sucking in heat from the environment, from the water, right? And it's endothermic, all right? So we want to fix this. Please don't forget to do step 3. You always want to flip the sign when you're doing calorimetry. So I'm putting that result down on the bottom left. Next, what we want to do is we want to calculate the moles of ammonium nitrate. And so here I'm just jumping past stuff that we've done previously many times. To go from grams to moles, you divide by the molar mass. So we get 0.0545 moles of ammonium nitrate, okay? And now we want to calculate the delta H reaction. I call this the change of enthalpy of the reaction, or the heat of reaction, okay? Because H just means heat, basically, all right? So this is the formula you want to use. It's just delta H divided by moles. Delta H is 1.2, as we saw, and the moles is 0.0545 moles. And so when you divide these two, you get a positive value on your calculator of 22.0 kilojoules per mole. So that right there is the heat of reaction in units of kilojoules per mole, and that's how you do it, okay? There's 5 steps. I'll show you the necessary formulas at the very end of this talk, all right? So we want to go through and check the sign, all right? Delta H is positive. It's endothermic. The reaction cools down. The final temperature is lower than the initial temperature. So in your mind, you're thinking check, 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 check. Yeah, everything checks out. That makes sense. And this is actually used in instant cold packs. The way this works is there's solid ammonium nitrate on the outside of the bag, and inside is a sealed bag of water. And when you twist it like so, the inner bag breaks easily, releases water, makes it mix with the ammonium nitrate, and it gets cold, and you put that on your shoulder injury or something. All right? So this is used in instant cold packs, believe it or not. Let's review the concepts here. If a reaction heats up or cools down, and the reaction is carried out in water, the water is very simply going to change in temperature. So we can calculate the change in temperature, we can calculate the heat flow, we can calculate delta H, and finally the heat of reaction. So this is absolutely a great technique for figuring out the heats of many different chemical reactions. Last but not least, I promised you a list of all the formulas used. These are the ones you probably want to write down on a note card or have handy for reference as you move through those 5 steps in the calorimetry calculations. The grams to moles here hasn't been listed because I figure you know that already. Thanks for watching. Please like, give it a thumbs up, and please subscribe to my channel to help support my channel. Thanks, and have a great day, everybody.